All right, here's a few exponent log transformation type questions. This first one says, how is this function transformed to become this function? You notice the d value stays the same, so it's only this number out front. And that number out front, going from 1 to 25, I can look at in two different ways. Like my normal function looks like this, a f of bx minus c plus d. That's sort of the transformation guideline. And so having a number out front of this x, I could think of it as a b value, or I could think of it as an a value. If you think of it as an a value, then what you have to do is take all of your y values and multiply them by 25. That's what the a value would say. And if you do graph this, if you were just to graph the two of them, you'd see that for every x value, no y value for this one, in this one it'd be multiplied by 25. And you could see the difference in the graph. The first graph looks like this, the second graph looks like this. And what's happened is it's vertically stretched. You can also think of it as being a b value, but right now it's not in the brackets, but I could change that. I could write it like this, 5x all squared plus 7. And that way it's in the brackets like it is here, and so you could call that a b value. And so what you're doing is you're dividing all of the x values by 5. And it turns out that if you do this, and try it, you can graph this or you can graph this, and they'll both look exactly the same. If you think of it as an a value, you're vertically stretching it by a factor of 25. If you think of it as a b value, then you're dividing all your x values by 5. In other words, you're horizontally compressing it. Okay, so that's that one. Here's another question that asks you to solve this exponential equation. Issue with this one is I've got three terms. Not terms, but three factors. And what I'd like to do is get this equation so I have one thing on this side is equal to one thing on that side. If I can get both of these to be the same base, all the better. And I think that I can in this one, because 81 is 3 to the 4th is equal to, 3 is already base 3, so we'll leave that, times 9 is 3 squared to the x squared. Yeah. Okay, let me just simplify this. I'll just multiply that. That's a power of a power. 7x times 3 to the 2x squared. Okay, now these two 3's, they're common base, so if I'm multiplying them, I can add their exponents. So it'd be 3 to the 7x plus 2x squared is equal to 3 to the 4th. Now I can use the same base rule. So if this base is the same as this, then the exponents must be equal to each other. So I can just write 4 is equal to 7x plus 2x squared. Since it's a quadratic, I'll bring everything to the right side. So the 4 will become a negative 4, make it equal to 0. And now we'll try and factor that thing. I think I can factor it. I think I'll get plus, not 8, 4. Plus 4 on this side and a minus 1 on that side. Let's just see if that's right. 2x squared plus 8 minus 1. Yeah, that's 7. Yeah, that's right. So now I can say either 2x minus 1 is 0 or x plus 4 is 0. So here I'll get x is equal to a half. Here x is equal to negative 4. So if I plug in either one of those numbers in up here for x, there, and there, they should equal to each other. Let's try one. Let's maybe try the negative 4, see if it works. So 81 is equal to 3 to the 7 times negative 4 times 9 to the negative 4 squared. Well, I wonder if this is going to work. So 7 times negative 4 is negative 28 times 9 to the negative 4 squared would be a positive 16. Ooh, I don't know. I guess I can figure that out on my calculator if I wanted to. Or I can just do this. 9 is the same as 3 squared to the 16th. So 3 to the minus 28 times 3 to the 32. Oh, there we go. If I add those, I get 3 to the 4th, and that's what 81 is equal to. Yeah, so that one works. And you could do the same thing with a half. I just chose not to do the half because 7 times a half wasn't giving me a nice number. This equation, I didn't solve any of these in the videos. I'm actually not going to worry about doing this one. Don't worry about that one. There are ways to solve it by, you can let y equals e to the x. That would be one way of doing it. Another way you could do it is multiply every term by an e to the x and see what you come up with, but don't worry about that question for this exam. Okay, here's another one. It says radioactive isotopes have a half-life of 252 years. That's a key thing. They say half-life, and that means if a piece of metal has maybe 10 grams, after 252 years, it becomes 5 grams, or half of what it originally started with. So if I look at my formula, e to the kt, this is what it starts with, this is what it ends with. So if I start with 10 grams, I'm going to end with 5, and I'm going to do that after 252 years. And so there I've got an equation where I can solve for k. First thing I'll do is divide both sides by 10 to isolate this part. So I'll get a half is equal to e to the k times 252. And then I'll change it from exponential form to log form. So it'll be log base e of a half is equal to k times 252. And then log base e of a half, log base e is the same as ln. So ln of a half is equal to k times 252. And then just divide both sides by 252. And that'll tell you what your k value is. And k value is going to be a very small number. I won't do it, but that's how you solve that question. And they're just basically looking for k. A nice question would have been how long would it take for the thing to be, say, 50% of what it originally started with. And then you'd have to use this k value that you got in another question. Maybe I'll just set that up too. So that if they say how long until you, 50% would be the half-life, right? Let's use a different number, a different percentage. Let's say how long until it's 75% of what it started with. So you'd say with your formula, so start, say, at 100%, and they say how long until you have 75% left. So 75 would be there. E to the k, you'd bring that number in right there, times t, and in that case you'd solve for t. And you'd solve it the same way as we did it. We did that one. Okay, question. Solve this log equation. So the first thing I want to do is I want to squish these two logs together. Since it's a plus, it's a product rule. So it'd be log base 2 of the product of x plus 5 times x minus 5 is equal to 1. Now that it's squished, now I can change this from log form to exponential form. So the base is 2, so it'd be 2 to the first is equal to x plus 5 times x minus 5. 2 to the first is just 2. If I FOIL this out, it becomes x squared minus 5x plus 5x minus 25. These will cancel, so I have 2 is equal to x squared minus 25. It's a quadratic, but there's no x term, so I'm going to add 25 to this side and to this side. So I get x squared is equal to 27. And then to solve for x, I can take the square root of both sides. So the square root of 27 is equal to x. And when I use the square root principle, I have to put a plus or minus there. Now, the other thing I need to do is plug this in and see if it would break my rule of taking the log of a negative number. This here is about 5 point something, 5.1, whatever. So it's plus or minus 5.1. Putting a positive 5.1 in here works. In here also works. But if you put a negative 5 here, you're going to get negative 5 minus 5 would be a negative 10, and you can't take the logarithm of a negative number. So that means I would cancel out the negative version of that. So I would just say x is equal to the positive square root of 27. I think you could simplify that. That's a root of 9 and a root of 3. So you could call it 3 root 3. Or you could, depending on the question, you could give an approximation of 5 point something or other. All right, hopefully that helps you with those exponent log questions.